Hello, everyone, and welcome to our 30-minute webinar titled An Introduction to Dicyclopentadiene. Thank you for joining us. My name is Brian Graves, and joining me today is Matt Getty, who's Vice President of Business Development here at Romeo Rim. But we also have a special guest today from Zeon Chemicals, the maker of their brand of DCPD called Telenet. Please welcome Brian Stubbs. How you doing, Brian?
Doing well. Thanks for having me, guys.
Good. So today we're going to be discussing all things dicyclopentadiene, or DCPD. We're going to first tell you a little bit about Romeo Rim and Zeon Chemicals. Then we're going to dive into what exactly is DCPD. Then we'll talk about what the DCPD process looks like, some of the advantages of using DCPD, and we will show you some real-life applications for DCPD. But first, before we get started, I'd like to mention that this webinar will be recorded and a link will be emailed to you for future reference or sharing. And in fact, if you really like the subject matter, we encourage you to share this among your social circle with your colleagues. We feel that if you had got value from this, that your colleague would too. Secondly, we'll be answering some questions at the conclusion of this presentation, which should last no longer than 30 minutes. So feel free to submit any questions you have in the field provided in the questions section of your dashboard. Any questions not answered live will be answered in a follow-up email. And finally, please stay to the webinar because I have some bonus material for you that might help you save some time. So with that, let's get started. Matt, can you give us a quick rundown of Romeo Rim?
Absolutely, Brian, appreciate it. So for those of you who are not familiar with Romeo Rim, we are a leading reaction injection molder in North America. That actually is our headquarters and the picture on the right that you see on your screen. And we do reaction injection molding of polyurethanes and of course DCPD, or dicyclopentadiene, is the focus of this conversation is today. We've been in business at Romeo since 1982 for a pretty good long time now. And we have two manufacturing plants here in Romeo, Michigan, with manufacturing floor space of about 200,000 square feet. So we do closed mold reaction injection molding, which is what the DCPD process falls under. But we also have another process called long fiber injection, or LFI, which is taking fiberglass, binding it with polyurethane in an open mold spray process. So to talk a little bit about how we handle our business, just so everyone can understand, what we really want to focus on is partnering with people in the industry. That could be customers, suppliers, or just general people in the industry, which Brian Stubbs is a great example of that as one of our suppliers for DCPD helping us today. And what that allows us to do is really understand the challenges that are in the industry, what's going on with our customers, really be able to provide the best solutions possible to our customers. The second step of what we do is the innovation phase. It's the create, which is that middle box there. So once we understand what the challenges are in the marketplace, we move to the innovation piece. So that could be modifying our processes or just creating creative designs for technologies for our customers. And then finally, we move on to that last box there on the right, which is deploy. And that's actually the execution. So once we have the knowledge of the industry through the partnerships, we innovate the products or the processes in the create phase, then we deploy it to our customers to make sure that we actually get the value to the marketplace. So that's how we operate our business. So to give you a little bit of an overview, this chart is really the great place to start because it talks about where reaction injection molding and DCPD in particular fits among other processes that you may know about. So real quickly here, the boxes that you see in the middle that are in the green, long fiber injection, and also in the blue, reaction injection molding, that's the focus of Romeo Rim. DCPD falls in that blue box there. So as you look at this chart, as you go up in the scales on the vertical axis, talking about large parts, as you'll see those boxes for Romeo Rim are really in that middle to the large component sizes. And so what we mean by that is we can make parts typically on the small side of 2 feet by 2 feet, but for us, we can make parts almost up to 12 foot and 12 foot in size. So pretty big stuff what we're talking about. Now, as you look at the chart on the left and you move to the right, everything that you see in those boxes that's going to be on the left-hand side is talking about high volume stuff, hundreds of thousands of shots a year, 100,000 units a year. So you're going to have lower piece prices, but you're going to have higher tooling costs typically there. And if you look at the opposite end of that scale to the right, you're typically going to have those lower tooling costs, but you're going to have a higher piece price that goes with it. So for Romeo and DCPD in particular, we kind of fall in those middle ranges. We say usually that sweet spot's around 800 units a year up to say 15,000 units a year. And of course, there's caveats to it. You go down a little bit or up a little bit, but that's usually where the sweet spot is. So wanted to make sure everybody understood that that's out there. You can kind of see where the technology fits if you're in those businesses. And with that, we're going to really make the shift now and focus on the DCPD conversation. So you can see how it may fit or add value to your business or parts right now. So I will hand it over to Mr. Brian Stubbs to take it from here and give us a good education on DCPD.
Great, I appreciate it, Matt, and thanks for the opportunity to speak with everybody today. And I appreciate everybody that's taken the time to phone in or log in for this. Hopefully will be a very informative webinar for everybody. I am Brian Stubbs. I'm the Senior Market Development for the Telenet product in North America. Do I have an echo, or is that somebody's?
You're kind of going in and out a little bit on my end.
Okay. Is this a little bit better?
No, it's like you're choppy. We apologize.
Yeah, I think you guys were a little choppy too for me, so I hope that's not causing a problem here with the connection. At any rate, let me move on. But Zeon Chemicals is a global specialty polymers and elastomers and chemical company. What you see on the screen now are some of the different products that we manufacture globally. We're about 3,000 people globally. And so we're involved in everything from synthetic elastomers that are used for hoses, belts, gaskets, turbo hose, things like that, through the specialty division, which is where the DCPD product is utilized. I don't have control, so if you guys want to flip to the next slide.
Yes, yeah, you have control.
There we go. Okay. So what is DCPD? DCPD is a thermoset polymer system. It's basically a liquid component A and a liquid component B. What you see is a simplified representation of how the material is processed. For example, at Romeo Rim and their molding operation, you have accurate meter mix dispensing systems. They mix these two liquid components to a mix head where they mix by impingement, and you have a reactive liquid that then flows into the tool and cures and mold opens, and we have there we go. Matt already has indicated that the typical volume is in that 800 to 15,000 range. It's also for very large parts. So sort of a medium series volume, but large parts that are subject to a lot of damage, a lot of repeated impact, thermal environments, corrosive environments, and that sort of thing. One of the big benefits is that it's very easy to develop a very high level of Class A finish for painting. So you see a lot of applications in subsequent slides where we show construction equipment, heavy truck, ag equipment, that sort of thing. The surface loves typical two-component polyurethane paint systems that are used in the industry. So whether it be for industrial type coatings or automotive type coatings, it's excellent surface. The process itself is a very low temperature and low pressure. So one other advantage is tooling costs. Matt indicated that in some of the higher volume applications, thermoplastic injection molding, compression molding, sheet molding compound, things like that, You're a little bit more automated, and so lower material costs possibly, but the tooling cost is extremely high in those applications. So where we really fit is in that middle sort of medium series volume, where customers who have high physical property and high damage tolerance requirements, large parts, but maybe medium series volume. So the tooling really works quite well, and the process works well for those applications. Okay. Whoops. Yeah, this is jumping a little bit on me here, Brian.
Which one do you need?
That one. I guess that's the next one, right? So we talked a little bit about the damage tolerance. I mean, the DCPD is really an excellent choice where high levels of impact, abuse, things like that are encountered in the application. It's a thermoset material, highly cross-linked, so has excellent temperature extremes, particularly the low temperature extremes, but also a high HDT. Telene is an unfilled system, so it's a neat polymer. So the molded density is very light compared to other materials. So we're talking 1.03 specific gravity. Excellent in corrosion, wastewater treatment, high corrosion exposure to corrosive and basic materials. So we have a lot of applications in marine. It's very the material will not absorb moisture, absorb water, so it's a good application for subsea, and we have a lot of applications for marine oil and gas and marine applications and shipboard applications and so forth. Let me see if I can get that. I'm not sure how well this video is working for you here, but you can see this gentleman is taking a pretty good whack at this hood with a sledgehammer. And the material is an excellent choice, and really the material of choice for construction and agriculture and vocational truck applications. I don't know whether I have a lag here, but I can't get, there we go. One of the things that on material specs, and I would definitely say that, we jumped ahead. Sorry, guys. This thing is bouncing back and forth for me, but a little
slow for you. That's all.
Yeah, a little bit about the equipment. Telene is processed using standard reaction injection molding equipment. So similar to the equipment that Romeo uses for polyurethane, exactly the same equipment is used for DCPD. One of the benefits with that is that as an end user and Romeo as your vendor, let's say, for example, that your volumes increase, or the material works quite well for your application, and you look for other solution to other problems using this. Having Romeo step up their output for you is really very straightforward. The metering units themselves are very modular, so that it's really a plug and play sort of application. So Romeo can expand using one metering unit, can actually operate up to 6 or 8 presses, 6 or 8 tools at a time. So it's not a huge overwhelming investment for Romeo as your vendor to expand their capability for you. It's a high pressure mixing. A lot of times you'll hear RIM addressed as a high pressure process, but that's really only the mixing, because then the material, once it's injected into the mix head, it mixes by impingement. You have a reactive liquid that's flowing through the runner and the gate system into the cavity, but basically drops to atmospheric pressure at that point for the most part. Usually aluminum tools. We have a couple of slides later. We'll show an example of a nickel shell tool, but really because it's a low pressure process, P20 tool steel is not required. Tooling costs are typically on the order of about 40%, 40 to 50% the cost of a typical injection mold tool or compression mold tool. So it's really quite an economical approach to get into this process. The material does not require a post cure. As we said earlier, it readily accepts paint. The 2-component paint systems love the surface, so there's an excellent bond to the surface. And with the Telenet systems, they're much more robust systems than some of our competitors' DCPDs, and so we do not require a nitrogen purge during the process, which saves cost and timing. Another benefit, it's a very fast cycle time. So if you're looking currently at RTM, open mold, hand layup type applications right now, and you're looking to make the move from that current process into DCPD or closed mold, it's a very, very fast cycle time. Typical body panel, typical enclosure type panel, you're talking about a 3 to 6 minute button to button cycle time. And by button to button cycle, what I mean is that the Romeo operator presses the button to close the press and start the process, inject the material, cure, time out the cure, open the mold, strip the part from the mold, and then be ready to start the next cycle and push the button for the next cycle. So very, very fast. Typical curing time for the material, 4 to 6 millimeter thickness, is about 90 seconds or less. But one comment I would make is that that's very adjustable to very large parts. I mean, we have some chemical industry applications where those shots are upwards of 200 kilos. I think the largest one we have is for a cell top cover that was almost 400 kilograms. And so the material can be adjusted to longer working times by the introduction of a retarder. What does that mean for you? That means flexibility in doing extremely large parts if you happen to have them, but it also means flexibility for your supplier, Romeo, in that they don't have to go out and buy the world's largest rim molding piece of equipment. We can actually adjust the chemistry of the system to compensate for additional working time. Another one that we get asked quite often is, what about prototyping? Okay, I want to prove my concept before I make the investment and I make the leap. We have people that are prototyping, and we've been involved in prototyping efforts at Romeo and at other molders around the world with a variety of different prototype materials. How inexpensively, how quickly you're able to do that really depends on what your demands are as an end user. Are you simply looking for a functional part? Does it need to have cosmetic appeal, for marketing evaluation and/or presentations and that sort of thing? But you can run anything from simple MDF, CNC machined MDF tools, wrench shape, up through polyester and epoxy laminated tools, and even to partially completed aluminum tools, depending on the number of parts that are required for prototyping, the cosmetic level, the complexity of the part geometry, dimensional tolerances, etc. What you see on the screen right now is an example of a part that was done for a tracked bulldozer vehicle that was done with wrench shape, CNC wrench shape tools, and about, I think, a dozen or 15 parts were generated for field trials and actual validation and testing in the field on this particular tractor. But there's any number of different examples. Romeo has quite a lot of experience in prototyping. So I would suggest that if anybody has any questions or a desire, please contact Brian or Matt or me directly. But it's definitely an option, and there's a high level of experience in doing this at Romeo. Again, the tool options. Whoops! Somehow we bounced back. Brian, can you move it forward? There we go. Typical tooling, production tooling, is either going to be nickel shelf or
I think it's just really laggy. Sorry.
Oh, now it's bounced forward yet again. I don't know why this. Here's an example of, also we talked about the size of the tools, the surface finish capability. The photograph you see on the left is a multi-cavity tractor fender tool that had a very, very high level of surface finish requirement. And one thing about Telenet and this process, the rim process, is that you can duplicate the surface finish of the tool extremely well. So in this particular case, we had almost a near Class A finish was developed in the molded part coming out of the tool. So the substrate in terms required very little preparation for the paint finish to achieve the level of surface finish required by the end user on that particular part. On the right, you can see an image there. It gives you a sense of scale of some of the sizes of the parts that can be done. Both of these are, by the way, are examples of Romeo applications. So you can see that Romeo has a very high, very large, part size capability on site there. So. Applications. We talk about some of the applications that are out there. We've talked about construction and agriculture. I mean, these are vehicles that see temperature extremes. They see abuse and impact. Lots of under hood temperature. The new Tier 4 exhaust emissions have been a big issue for agriculture and construction OEMs. But Telenet has the ability to withstand the heat. So. Let's see. Again, more examples of large parts, again, subject to incredible amounts of abuse. The center picture that you see on the bottom there is articulated, off-road articulated hauler. That's one where we worked with the OEM on that to consolidate from multiple parts into one. That entire hood and the entire inner reinforcement that is adhesively bonded, those are one piece. So it's a one piece outer skin, one piece inner skin. I think that entire part combined is about 150 pounds. Lower right hand corner, that wheel loader hood is a new model that was introduced a couple of years ago. Again, it's multiple pieces, but combination of structural fasteners as well as adhesive bonding. In addition to one thing we didn't mention, but in addition to accepting paint extremely well, there's quite a number of adhesives that work very well with Telenet. There's epoxy systems, polyurethane systems, MMA, methacrylate systems. These are all used quite regularly in everything from heavy trucks to construction and ag and industrial applications. Again, off-road, these are mining applications, extreme temperatures, vibration, impact, temperature. It's all areas where the material excels, and it's really the material of choice in these type of heavy equipment applications. Ag, construction, again, same thing. These are several of these examples. The orange man lift is another one that was extensively prototyped in fiberglass tools before that was taken to market. So, validation, engineering validation parts can be easily produced by Romeo to give you actual hands-on product to test with. Trucks, heavy trucks. This is another application, lightweight. High level of surface finish and quality, paintability, serviceability, all of these things, particularly as the heavy truck industry heads toward fuel efficiency, greenhouse gas standards that are being implemented and so forth, low aerodynamics, the ability to mold complex part geometries that aid in aerodynamics and fuel efficiency, lightweight for fuel efficiency, braking and suspension systems enhancements and things like that. It sees a tremendous amount of application on heavy truck. Bus is also the bus applications. Front fascias, side skirts, access panels, CNG, fuel tank covers, you name it, battery boxes, electric vehicles. We're seeing a lot of, particularly the corrosive performance and anti-corrosion nature of the material. It's another application is in EV. We're seeing a tremendous rise in applications there. One of the things that I know that the Romeo guys have talked about and I've mentioned is that the rim process gives you the ability to do very complex part geometries molded in one shot, as opposed to having to do multiple components that are later assembled, that sort of thing. you know, it's the ability to do thick and thin cross sections and bosses and ribs and so forth. And then that upper left, you see that photograph of the kind of the figure 8 part there is the commercial mower deck. So one of the examples that I like to show, and the complexity of molded part capability, as well as the damage tolerance. You know, anybody who's run over a rock or a stick or something in their lawnmower knows that how violent that impact can be. So there's a one-piece molded commercial mower deck that's been molded from Telenet, kind of gives a good representation of the capabilities. But you see the wide variety of products that are from transportation to industrial to wastewater management, marine, you name it. There's all kinds of applications for this material. So I think that's it for the slides that I have. So I don't know how thrifty I was with time, but I'll turn it back over to Matt.
Brian, great job. Really appreciate it. I thought those examples of how and where to use DCPD in the market were phenomenal. Really gets your mind thinking about different applications and the uses for it. So really appreciate you sharing those and helping to educate us all on, you know, where to use DCPD and what the benefits are. So for everybody else as well that's still out there, check out the projects here and the information here. So if you've got an idea that you want to talk about that you think DCPD may be a great fit for, here's how to get a hold of us and get started. Step one, of course, is get a hold of us through email. That's a pretty simple way to do it. The other way is giving us a call on the phone number that you see here. Or another way is just even go to the website and there's a contact information page there as well. We can get started through that. So once you do that and you get a hold of us, what we'll do is we'll have either sales or engineers or maybe both get a hold of you, get any drawings, CAD information that you may have on your project, and we'll start assessing it with you. And then furthermore, we'll get all the specifications, understand the finishes that go with it, the use of the application, really guide you from that standpoint. And especially on these DCPD applications, we will also use Mr. Brian Stubbs here, who was presenting as well, as a resource to help guide on how to design it and how to make it function for what your application is. So a lot of resources here to make sure that your projects are a success, and we hope you reach out to us for that. So with that being said, I will hand it back over to Brian Graves here to wrap it up with some question and answer.
All right, thanks, Matt. Thanks, Brian. We have a couple minutes left, and I just want to get to a couple of questions that came in. So, Brian, if you wouldn't mind answering, what kind of adhesive works with DCPD?
We see a variety of adhesives used commercially for many, many years. I'd say the most common ones that are used right now in the industry are methacrylates. So for example, like not necessarily to give somebody credit here, but like a Plexus AO420 is kind of a benchmark for most folks. Acryloc, Lord, you know, they all make methacrylates that are commonly in use. Polyurethane adhesives, you know, so the plyo grips of the world, you know, Ashland, for example, commonly in use, trucks and buses, and epoxies are quite often used. We also have some silanes in use in Europe, but I would say that the most common ones are going to be your methacrylates, your polyurethanes, and your epoxies.
Okay, great. And we talked about how big of parts DCPD can make. One of the questions is, how big of a part can you make with DCPD?
Really, size is almost unlimited. As I think I mentioned while I was talking, we've in the chemical manufacturing industry, because of the corrosive resistance nature of the material, it's used quite extensively in large pipe fittings and cell top covers for in the chloralkali generation. But we've got some that are upwards of 200 kilos. So, you know, you're talking 450 to plus pounds. So really the size is unlimited. Most body panels are going to be in the 4 to 6 millimeter cross section range, but we have industrial applications that are up to 8 or 10 inches thick.
Okay, great. This will be the final question, and then we'll get right to the bonus material. So What kind of paint systems are compatible with DCPD?
Most common paint systems in use today are two-component polyurethane paint systems. So typical automotive, or the Polanes and Sherwin-Williams and PPG and all sorts of automotive two-component polyurethane paints have excellent adhesion, offer both wet and dry adhesion performance, and excellent durability.
Okay, great. That's all the time we have for today. I'd like to thank Brian for speaking and Matt for telling us about Romeo. And as promised, here's our bonus material. We put together a composite material selection app where you can go and answer a few questions about your project, and it will spit out a short list of suitable materials where you can begin your research. We hope that this tool is used to help you save time in that process and to identify an appropriate material for your project. We've also put together an infographic that kind of explains at a glance all the different materials or options that are available to you. So you're welcome to download that. That is in the handout section of your dashboard. And it will also be made available in the follow-up email tomorrow, where you will also get a recording of this to share. Finally, our next webinar is going to be on solid elastomers, the large mid-volume parts with great surface finishes. That'll take place Wednesday, May 28th, May 29th at noon. If you don't know what solid elastomers is, that'd be a good way to find out. So follow us, Twitter, Instagram, Facebook, LinkedIn, YouTube. And thank you for attending. It was a pleasure hosting this webinar for you.